Hello, and here is another example of electrostatics versus gravitational. This is an example from a former exam question. Here, the magnitude of the electrostatic force can be compared with the magnitude of the gravitational force. The problem involves a helium nucleus containing two protons, positive charge E, so therefore repelling each other, of mass m. There are no numerical values given in this question. One has to go to the fundamental equations for these two forces to get an expression in terms of their forces. Then common terms can be cancelled before substituting in numerical values with units. So the problem is, for two protons of mass m italicized and charge plus E also italicized in a helium nucleus, we can compare the forces of gravity and electrostatics. The first equation we have is the force of gravity. As a vector notation, equals minus g m1, m2, the product of the masses, divided by the square of the distance between them, r squared, in the r hat direction. m1 equals m2, which equals m, so you just simply replace the m1, m2 by m squared. So now I have f grav equals minus gm squared over r squared in the r hat direction. The constant of gravity is 6.673 times 10 to minus 11 Newton meter squared per kilogram squared. Similarly, you take the electrostatic force, subscript elec, and it's plus or minus the constant k, the product of the two charges q1, q2, divided by the square of the distance between them, r squared, in the r hat direction, and it's positive, changes from plus or minus to positive because the charges are the same, therefore they repel. q1 equals q2 equals q, therefore kq1 over q2, kq1 q2 over r squared becomes ke, because of changing the charge to e, the letter e squared over r squared in the r hat direction. Conversely, the constant of electrostatics is a large number. It's 1 over 4 pi epsilon naught, which is 8.988 times 10 to the 9 Newton meter squared per coulomb squared, normally rounded to 9 times 10 to the 9, a nice easy number to remember. So we can now compare these two equations. We have f grav equals minus gm squared over r squared r hat, f elec equals plus ke squared over r squared r hat. I want to get the modulus, the size of it, so I'll just give the modular sign, and then of course the minus sign will drop out, and I'm not worried about the unit vector, it's the same nucleus, so it becomes gm squared over r squared, and the same for the plus, of course, is not affected, ke squared over r squared is here. Then I divide them, so the electrostatic force divided by the gravitational force is ke squared over r squared divided by gm squared over r squared. And then when you divide a fraction, if you then flip it, you can multiply by flipping the inverse, inverting the fraction by inverting it. Of course, the r squares will now cancel, end up with ke squared over gm squared, and only now do you substitute in numerical values with units, because if you do it before that, you'll end up with a nightmare, with you can easily make a mistake. So you put in k, again with the units, 8.988 times 10 to the 9 Newton meter squared per coulomb squared. The charge of a proton, which is 1.602 times 10 to the minus 19, that is squared. G, which is 6.673 times 10 to the minus 11 Newton meter squared per kilogram squared, and the mass, which is 1.673 times 10 to the minus 27 kilogram squared. Square these two identities first, leave the k and the g value alone, one step at a time in your calculations, makes it so much easier to see if you make a mistake, and you can double check your powers of 10, because here we have 8 times 2, which is about 16, that's 1 power positive, plus another power positive, which is 10 to the 10, minus 38 is minus 27, minus 27 minus 28, 6 times 2 is 12, that's power of 1, minus 11 becomes minus 10, minus 54, but minus 64, there we go. So double check that these look at the right order. You then have Newton meter squared per coulomb squared, and this is coulomb squared here, so these terms will disappear. Again, kilogram to minus 2 times kilogram squared. These two terms will disappear, and the newtons, top and bottom, will disappear. You'll end up, as expected, when you divide two identical identities, the units will drop out. And that's the actual numerical value. So the conclusion is about the force of electrostatics is 10 to the 36, which is a huge number, times stronger than the force of gravity. So in the terms of a nucleus, electrostatics wins every time, because the so-called gravitational constant is an incredibly small number and actually very difficult to measure. That concludes that one. So any comments in the comment box, any likes, shares, whatever, thank you much indeed. Thank you.